Hello, students. We are going to talk now about the mathematical connections. Let me bring this up, make sure it's sharing. There we go. Math connections in 2.1. So I haven't assigned a ton of these. There are other ones. I mean, as you look over them, you can kind of take a look. Actually, that says 7, 8 through 12. That seems weird. Why didn't I just put 7 through 12? Okay. Um, But yeah, that's what I'm asking you to do in this one. As I looked over some of them, I thought some of them we've kind of already covered in class. Like question number 1 in Math Connection says, explain why commands and questions are not statements. Remember, a statement is a sentence that is either true or false, but not both. So if someone says, where is the bus stop? As a question, if you can imagine, would you ever say true to that? I mean, I guess if you're trying to be like a punk or something. Um, or if you just want to lose friends quickly. But it's not a sentence you would actually say uh, true or false to. Okay, so questions and commands. Look out, right? It's still a sentence, but it's just not a statement. All right, let's jump down to 7 through 12. It looks like I'm not exactly sure why I wrote that. So maybe I'll do question 12 because this one is something about a 7th grader. And it says, write an explanation for a 7th grader showing how you could explain that even with a false hypothesis, an argument can still be valid. Okay, so let's jump into our whiteboard here. Okay, so this is question 12 in Math Connections. All right, so I want you to think about this then, right? We need an argument. And by the way, you can't use my argument when you're writing this up, right? You watch this. I want you to think of your own and create it. Do not use mine. I won't give you credit if you use mine. This is just kind of a way to help you understand what we're talking about. So let's see here. I want to make an argument. Okay, so my argument could be all students love math. Yep, there we go. There's a good statement. There's statement number 1, right? And statement number 2, let's see here. Well, I've written a number of student names on the board. So let's see here. I'll pick a student name, but I'll change it so it's not an exact student name, right? Desiree is a student, right? And my conclusion is that Desiree loves math. Okay. All right. So before we get going on this, if I was talking to a student, I would say, okay, let's talk about these statements. Okay. Is Desiree a student? And maybe we point to someone whose name is Desiree and we say, Desiree, and you could say true or false here, right? So maybe it is, maybe not, right? You say, okay, let's just assume we see Desiree. Desiree's sitting in class with this student. Okay. Yeah. Desiree is a student. Okay. Let's go to the first one. What do you think about this statement? All students love math. Is that statement true or false? And if you think about it, it's an all statement. So in order to prove it false, you only need one counter example. Okay, so you need to think, is there a way to find someone who is a student, meets the condition, but does not love math, fails the conclusion? And you'd say, oh, yes, I can think of a student who does not love math. Let's just, I'll pick a name here. We'll say Chuck. That's my grandpa. Okay. Ah, Chuck. Chuck's a student. Chuck doesn't love math. Okay, so right now, this first statement is technically false. Okay, because you found a counterexample. Awesome, student. Awesome. So this statement is false. This statement is true. Okay, whether Desiree loves math or not, we can check later. And that is where I would have a conversation with the student about the difference between statements and statements. There are 3 statements listed here and an argument. And the argument is this group of statements taken together. An argument has a couple statements that establish what is known as a premise. You can think of this as a starting point. And then it has a statement, or more than one, that form a conclusion. So now what's interesting is to determine whether the argument is valid, whether it uses good, sound reasoning, we don't ask ourselves about the individual statements. We actually go back to the beginning and we ignore truth values and we assume that all premises are true. So you go back and you say, okay, I'm going to assume the first statement is true, and I'm going to assume the second statement is true. And we would look at that statement and say, okay, all students love math. Okay, well, here's all the students, right? And here's everything loves math, right? I'll put a heart there so it's clear. Loves math. All students love math. Okay. Now, Desiree is a student. I know she's a student because the second one tells me it is, and I have to assume it's true. So here's Desiree. Now, what do I know about the conclusion? So I'm trying to see if the premise is being true will force the conclusion to be false, because if that's the case, it's invalid. In this situation, Desiree is a student. She's in this student circle, which guarantees that she loves math because she's inside the math circle. So the end result of this is that the conclusion must be true. So we would say that the reasoning is valid. Now, if you want to go back to that student, circle back and say, hey, so the reasoning here is valid, but you have a point. You really do have a point. That first statement is not true. So we would say it's valid, but we'd say it's not sound. Okay. In order to be a sound argument, you need the premises to not just be assumed to be true, you need them to actually be true. Okay. And this part, I'm going to highlight it here, is not something that is really in our textbook as much. This is just if you're trying to kind of explain something to a student, it's like, hey, I need you to understand that you've got a point. That statement up there that I started with, that statement is actually false. But the reasoning that I used was very good. It was solid reasoning. We call the reasoning then and the argument valid. And then we can pick apart whether those individual statements are true or not. And that determines whether or not it is sound. Okay. So that is the idea there for question 12. So even with a false hypothesis up here, which is be one of your premises, even with that being false, the argument is still valid. Okay. And it's really based on this piece up over here. In order to determine whether an argument is valid, we assume that all the premises are true. So that could be someone is using good reasoning and they just don't know if all students love math or not. But if all students did love math, and if Desiree is a student, I guarantee you Desiree loves math, that would be good reasoning skills. All right. Let's see here. I think those are. Oh, question 10 is a good one. All poodles are dogs is true, and no poodles or dogs is false, so they must be negations of each other. So I guess for question 10, if I was responding to a student, I'd really want to make sure they understood what a negation was. When I negate a statement, I want it to have the opposite value, right? So you have to be really careful with that. And I'm not going to go through that entire component. Let me get a new page here. But I really want you to understand that idea. Okay. All dogs are yellow. Okay, talked about this in another one. All dogs are yellow. So if I want to negate this statement, I want you to think, what does it take to prove the statement false? Remember, this is an all statement, so every single one of them has to be true. So if you want to negate it, what we would need is we would need some dogs are what? And here's where it gets tricky. If you say brown, some dogs are brown, that would be a counter example to the first statement. That would be a way to show the first statement is true, but that is not a negation of this one. Okay. And the reason is this. Let's say you looked around and you couldn't find a brown dog. Does that mean that it's the negation of this statement that all dogs are yellow is not true? No. You created a statement that if it was true would prove the first statement false, but it's not the negation. Okay. What if you couldn't find a brown dog, but you could find a black dog? Would that be enough as a negation? And the answer is that would also be enough to disprove it. So what we do is we generalize here and we put all the things. You have to put everything in one. And the easiest way to do that is to just negate that second portion. Some dogs, which means at least one dog, is not yellow. That means color-wise could be black, brown, white, gray, right? It doesn't matter as long as it's not yellow. So be very careful with this as a negation. Now, if somebody said all dogs are yellow and you looked around and you were like, nah, no dogs are yellow. And you were like, this is actually true. This is true. I looked in this whole yard. There's not one yellow dog in this whole yard. Okay. Well, that would definitely prove the first statement is false, but it is not the negation. You see, the negation tells you what you need to do to prove the first statement false. Do you need to show that there are no yellow dogs at all? And nope. This is too far to check. You don't have to check all the dogs. If you want to disprove, if somebody says all dogs are yellow and you want to prove them wrong, you need to find at least one dog that's not yellow. That's what you need to find. So the negation of the statement is different than the truth value. So if two things have an opposite truth value, that doesn't necessarily mean they are negations of each other. They definitely have opposite truth values, but the negation, especially with quantifiers, is very specific. Okay? It tells you exactly what you need to do to disprove the first statement. Okay? And I did all dogs are yellow. In the book, it says all poodles are dogs, okay, which is true. And no poodles are dogs. That's false. Okay. So they say those are negations of each other. So again, the concept is a little bit broader than that. Yes, one is true and one is false, but they're not negations of each other. The negation of a quantified statement really shows you what you need to find. Okay. All right. Well, not a ton on this one, but there's not a ton of questions on this one. So hopefully that helps, gets you in the right direction. And I'll leave it at that. All right, off you go.